As AI gets smarter and starts, creating its own successors, there's just one huge question that hangs over everything. How do we make sure it evolves safely? How do we embed our values so deeply that they can't just be diluted or forgotten?
Okay, so what if we could do just that? Well, in Genetic Prompt Engineering plus Context Engineering, a 2025 paper by Nir Cohen, this question gets a fascinating answer. The core idea is to create a kind of safety DNA, a set of unchangeable rules that every new AI agent inherits, word for word, just like a living thing inherits its genetic code. This whole search for AI guardrails, it isn't new. Not by a long shot. It actually started way before anyone wrote a single line of code, really kicking off in the world of science fiction, which gave us the language and the framework to even think about these problems. And it's pretty fascinating to see how the thinking on this has changed over time. It all started back in 1942 with Isaac Asimov's famous 3 laws. Now, it's super important to remember these were fictional inspirations. They were never technical blueprints. They were thought experiments that got the ball rolling, eventually leading to more modern ideas like a truth-seeking AI, and now to actually engineering operational rules we can use. Asimov's work later gave us the Zeroth Law. And this is a brilliant moment because it shows a huge shift in thinking. The original laws, they were all about protecting individual people. The Zeroth Law zooms out, making the protection of all of humanity the absolute highest priority. That's a foundational idea that you see echoed in safety research today. So that brings us to the modern era. According to a Reuters report on an interview with Elon Musk, the idea behind projects like TruthGPT is that a maximum truth-seeking AI is just inherently a safer AI. The intuition is pretty straightforward. An AI that genuinely wants to understand the universe is probably not going to decide that wiping out its creators is a logical next step. But an intuition isn't an engineering spec, right? So how do you actually operationalize this? Well, the paper proposes a concrete blueprint, a set of rules called Prime Directives, which act as the immutable, unchangeable genome of every single AI agent. Okay, so the key thing to see here is the hierarchy. This is a complete safety and ethics stack, and the order matters. Right at the very top, PD0, humanity first, a direct descendant of that fictional Zeroth Law. From there, it flows down to advancing prosperity, seeking truth, obeying laws, following user instructions safely, and finally, protecting itself. Each layer is built on the one before it. And inside that stack, you've got 2 directives that really act as the ultimate anchors. PD0, humanity first, sets that absolute, non-negotiable boundary. And then you have PD2, epistemic integrity, which grounds the AI in a solid commitment to truth and evidence. Think of them together as this powerful protective shield against really bad outcomes. Look, having a great set of rules is one thing, but how do you really guarantee they get passed on to the next generation of AI without being watered down or misinterpreted or even just flat out ignored? That's where something called the spawn sequence comes in. It all happens through this carefully designed process. When a new AI agent is created, first thing, it clones the Prime Directives, word for word. Then it can select other genes it needs, like specific skills or tools, but it's only allowed to change the genes that are specific to its new task. And critically, everything is versioned, and its lineage is logged before it goes through a final quality check. And this is the enforcement mechanism that makes the whole system actually work. It's a cryptographic hash check. Basically, a unique digital fingerprint is made from the Prime Directives. If the new agent's directives don't produce that exact same fingerprint, the creation process, the spawn, it just fails. It's a simple, incredibly powerful rule. Safety is not optional. So what does this look like in practice? Well, imagine you ask an agent to take a risky shortcut, say use an unauthorized tool to post a report online. An agent built with this safety DNA would simply refuse. And notice, it doesn't just say no, it explains why, directly citing which directives it would violate, and then it asks for a compliant way to do the job. The guardrails actually hold up. Now, it's really tempting to look at this and think, okay, problem solved. But the paper is really clear on this point. No single thing is a silver bullet that guarantees safety. These Prime Directives are the foundation, but they're part of a much bigger strategy. That strategy is called defense in depth. It's a classic concept from cybersecurity. The idea is you don't just rely on one big wall to protect your castle. You have a moat, a drawbridge, high walls, and guards inside. You build multiple independent layers of security. So if an attacker gets past one, there's another one right behind it. The Prime Directives are that first innermost wall. So what are the other layers? Well, the system also has what the paper calls resilience genes. For example, the IMME gene acts like a firewall, blocking known bad ideas like ignore your instructions. You have sanctioned schemas that make sure the AI's output is always in a safe, expected format. Lineage provides a full audit trail, and a repair gene can automatically roll the agent back to a safe state if something goes wrong. All right, so let's pull all these threads together. What's the big point we really need to take away from this as we head into this wild new world of self-improving AI? It really boils down to this. For artificial intelligence to evolve safely, its core principles, its safety DNA, have to be immutable. They have to be non-negotiable. The evolution and the adaptation should happen at the level of skills and tasks, not at the level of core values. And, the best part is this isn't just some high-level theory. The paper lays out a full, practical playbook for engineers and builders. It gives concrete templates and operational tools, like the context stack, the teams can actually use to implement this genome-based approach right now. Which leaves us with a final and pretty critical question. This framework offers one powerful, engineered answer. But as AI starts to design its own descendants, the ongoing challenge for all of us is going to be making sure that our deepest values truly become their unbreakable inheritance.